Calculator shortcut for these binomial probability problems. So if a fair die is rolled 6 times, what is the probability to the nearest thousandth of getting exactly 5 sixes? Alright, so what would we have had to do before? For exactly, we would have 6 rolls. We want something to happen 5 times. And the probability of rolling that would be 1 in 6 chances for rolling a fair die. We want it to happen 5 times. The chances of a failure is 5 out of 6 times. We want that to happen once. So this would give us the probability of exactly 5 sixes. But we have a calculator shortcut, which we're going to show you right now. So what's the calculator shortcut? It's called Binomial PDF. And this is for exactly. Alright, so this one says exactly 5 times. Let's find it. So we're going to go to the second function. So we're going to go second and distribute for the vars button right here. Then we're going to slide down here where it says Binomial PDF. Look, make sure you're hitting the PDF one. So what is this looking for? In Binomial PDF, we want the number of trials. So we're going to have the Binomial PDF 6 because there's 6 trials first. So I'm going to hit 6, comma. What's the probability of that happening? Well, that's 1/6, so I'm going to go 1 divided by 6, comma. And how many times do I want that to happen? 5. Close my parentheses. And as you would expect to get the same thing 5 times, that would be a pretty low probability. And that round to the nearest thousandths is 0.001. And we get approximately 0.001. If we put this in, 0.001. Round to the nearest thousand, so let's try that. And of course this was a lot quicker, 0.001. Enter and we get a nice and easy. So this is a quicker way to do this type of problem. Now the cumulative ones are the ones that at least at most are a little bit more difficult. So let me go back, do compound probably at least at most. At least 5 out of 6 games. Okay, so let's do this one. So it says that the probability that the Islanders will beat the Rangers in a game is 5 out of 6. That's the probability, 5-6. What is the probability the Islanders will win at least 5 out of 6 games in a series against the Rangers? Round your answer to the nearest thousandths. All right, so let's first of all look at what we were doing here. All right, so our probability is 5 out of 6. Okay, and we want to take 5 out of 6 games. So what would we have had to do before? If they win 5 out of 6, that means they could win 5 or they could win 6. So we would have to take the probability for 5 out of 6, which of course this would be, remember they're playing 6 games. We would win 5. The probability of winning is 5 out of 6, and we want that to happen 5 times. But if 5 out of 6 is the probability of winning, or the success, that means there's a 1 out of 6 chance of losing, and that would happen once. And then we'd have to add that to 6, choose 6 of 5, 6, that happening every time, and of course 1 out of 6 happening 0, and that's how we had to do it before. Well, now we have another thing called Binomial CDF, but there's a little bit more to CDF. You always have to use a probability of x less than or equal to something. Okay? And this one wants 5 or 6 wins. So if we have 5 or 6 wins, that means the opposite of that would be less than or equal to 4. So we have to always have everything in terms of less than or equal to 4. So in our binomial CDF, our probability here now, we have 6 trials. We have a 5/6 chance of winning, and we want that to be less than or equal to 4, which is the opposite of what we're looking for. But we always have to do binomial CDF in less than or equal to. So what does that tell us? We're going to go second, vars. We're going to go to binomial CDF down here. We're going to put in our number of trials, which is 6, comma, 5 divided by 6 for our probability, comma, and we want less than or equal to 4, okay, which gives us 0.26322, but remember that was the opposite of what we wanted. So our real answer is 1 minus 0.26322. So that's 0.737 rounded to the nearest thousands. Okay, so again, with binomial CDF, the cumulative, the at least or at most, we always have to put this in less than or equal to. So if we want 5 or 6 wins, that means we want 4 or less losses. So we have to calculate the 4 or less losses, the opposite of what we wanted, and then subtract it from 1. So we get 0.737. So we'll put in the 0.737 to get round to our nearest thousands, and it's get the same thing. So you got to be careful again with this binomial CDF because it has to be in terms of less than or equal to get this function correct. And we'll do some examples in class, of course, on Zoom.